Okay, in this section we're going to actually go to the configuration side. We're going to go implement a couple of types of NATs on the ASA firewall. We're going to do object NAT of type static and dynamic. We're going to do like a static static NAT using object NAT configuration, and we're going to do dynamic path or path using object NAT configuration. And finally, we're also going to look at an example of policy NAT using the twice NAT configuration. So looking at our diagram in here, because on the ASA, this is my inside interface. And this is my outside, as I called it, the internet interface. Internet. We're gonna assume that this is like the border of my network, where downstream in that direction is going to be the internet, and on the other side is going to be my LAN network, the private network. So what I want, let's suppose that, for example, let's look at server A in here, which has an address of .100 from VLAN 94, and because that's a private address which is not available on the internet, I would want that private address to be visible on the internet. I would want this 172.16.10.100 address on the LAN side, on the inside network, to be visible on the outside in here in the internet as, let's say, 136.1.47.100. So an address from this VLAN. And I'm going to do a static NAT for that because I want the transition to be always active. So I would want both server A to be able to initiate traffic out on the internet and get translated into that address, and also the internet to be able to access the server A on that publicly NATed or mapped IP address of server A. So we're going to do object NAT, and we're going to do a static NAT for this reason, because we want bidirectional communication back and forth to be available for that service. We're going to do just a static one-to-one mapping. So let's go on the, first we're going to go on the ASDM, do that from the ASDM, and then we're going to go to the CLI to see also the CLI configuration part. So looking at our ASDM, let's do a refresh to make sure we read the new configuration of the ASA. Again, we will find NAT configuration, it makes sense. It has to be a configuration. So we go under the configuration tab in here. Then it has to be, it's not a device setup. Again, it's not a remote access VPN configuration, not a site-to-site VPN, not a device management. It has to be under firewall section, and it's going to be under NAT rules. So as you can see, there are no NAT rules configured. Clearly the ASA doesn't have any built-in NAT rules in there. So we're going to say add, and we have three options in here, which are going to be based on those three sections. The ASA is going to order the NAT statements. So we have first what I call add NAT rule before network object NAT rules, which that's going to be a twice NAT statement. Then we have add network object NAT rule, which means object NAT. And then we have the add NAT rule after network object NAT rules, which means twice NAT, but we want the ASA to inspect that twice NAT rule after the regular twice NAT rules and after the object NAT rules. Because as I stated, given that, let's say, a packet flowing through the ASA may match on multiple NAT statements, the ASA is going to process top-down rules and stop on first match. So first is gonna check, does my packet match any twice NAT statements? If it doesn't, does my packet match any object NAT statements? If it doesn't, then does my packet match any twice NAT statements, but the twice NAT statements which are processed after object NAT? And if it doesn't, then the packet is going to be routed, assuming it's going to be allowed by the ASA rules, security levels, and access list. It's going to be routed as normal, not being netted. So I'm going to say add network object NAT rule. So in here, you define initially, in this section, you define in here the name of the object, which of course has to be something significant. Then what do you want to do? IPv4 or IPv4 IPv6 NAT. In this section, you tell the ASA what does the object contain. Does it contain a host, as we said in the overview part, a host, a range, or a network? Or of course, it could be also fully qualified domain name, which means the ASA would need to resolve that fully qualified domain name into an IP address, which means DNS has to also work. So that's not an option to put in there. Instead of putting a host, you can put a fully qualified domain name, which means the ASA is going to be dynamically resolve that name into an IP address in there. Then you put in here, you say you configure in here the NAT type, static, which is gonna be a one-to-one static mapping, always active. Dynamic, meaning is gonna be a one-to-one mapping dynamically built, or dynamic path, which means you're gonna translate all of the addresses that you configure in the object into a single IP address doing path. So in the object you put in here, let's say in the object you always configure the real address that you want to NAT, which is going to be test server A address. So you put in here, let's say the name of the object is going to be test server A object NAT, let's say test server A NAT, a static NAT, for example, static NAT. IP address, you put in here the real address of the server, 172.16.10.100. NAT type I said is going to be a static one, and ideally, as a rule of thumb, although you can configure the NAT statement by putting the interfaces, so as you're going to see configuration wise, the NAT statement is going to be something like NAT, and then you have to specify the ingress and the egress interface of the packet. And although you can put in there any, which means doesn't matter, you know, on which interface of the ASA the packet comes inbound, and doesn't matter on which ASA interface the packet gets routed outbound, if the traffic matches the NAT statement, traffic is gonna get netted. So although you can put any, it's recommended unless you properly understand the any keyword, because I mean you understand what any means. As I said before, if you put the any keyword as the ingress and egress interfaces, it means that doesn't matter where the traffic comes inbound, on which ASA interface, or on which ASA interface the packet gets routed outbound, if the traffic matches that statement, traffic is going to get netted. But behind the scenes, the any keyword does a lot of other, let's say, can cause a lot of issues due to the proxy ARP. What that means is that when the ASA is going to NAT, or when any device is going to NAT in general, an IP to another IP is going to proxy ARP for that NATed IP address. So that proxy ARPing capability can cause actually issues in a production network unless you properly understand how proxy ARP works. So in general, if you don't really understand the proxy ARP functionality of the ASA and the any keyword, it's recommended to put in there the specific interfaces, ingress and egress. And if you look at our traffic flow, so I have defined in my NAT statement server A, and I want to NAT server A as traffic flows through the ASA. So as traffic flows through the ASA from server A, I want to NAT server A into 136.1.47.100. So the ingress interface of the traffic flow is going to be this interface. So the ASA receives the traffic on the inside interface and is going to route it on the internet interface. That's going to be my egress interface. So it doesn't matter that from the traffic flow point of view, the ASA ends up doing source NAT or destination NAT. Again, configuration wise, except twice NAT, because NAT was designed to do source NAT to begin with. Back in the days, you would NAT the LAN with as it traffic went out on the internet. Because configuration wise, again, you always have to think, your mindset should be there. You do source NAT, you look at the traffic flow from the real IP address that you want to NAT, you look at the traffic flow, and that's how we identify what is the ingress interface and what is the egress interface. So as long as you remember that, ideally you do always source NAT. Then you look, okay, what is the source address what is the address that I want to NAT? Is server A. Then look at the traffic flow. Server A sends traffic to the ASA, and if looking at the traffic flow at that direction, you're gonna instantly be able to identify what is the ingress interface and what is the egress interface. So I'm gonna put in there also, we went to the advanced option in here at the bottom, and I'm gonna say my ingress interface, which is gonna be in here, signal as the source interface, is going to be inside, and the egress interface signal as destination interface is going to be the internet interface. So we put in there the inside, so traffic comes inbound on the inside, gets routed out on the internet. So only if traffic is routed between those two interfaces, NAT is going to happen. And I'm going to translate this address of server A into whatever I put in here, which means it's going to be 136.147.100. Now I'm going to say OK and apply and send. If you look now in the configuration part, what ended up happening on the ASA, show run object, you can say inline. We have one object defined as test server static NAT, which in the object you always identify, you put in there the real addresses that you want to NAT. And then if you say show run NAT, you're saying that whatever it's matched in that object, I want to do NAT, but only if traffic comes inbound on inside interface and goes outbound on the internet interface. I'm going to statically NAT server A address into this address. So you don't put in here NAT NAT interfaces ingress and egress, and you don't put the keyword as source or destination, because remember, as I said from back in the days, NAT was always source NAT to begin with. As you're going to see when I go to policy NAT, only twice NAT, because it allows you to do both source and destination NAT at the same time in one configuration line. In there, we're going to see that we have the source keyword and destination keywords in the NAT configuration. But otherwise, this implies, this configuration here, actually, the way you should look at it, it implies that in here, the keyword source is being added. So what you're saying is, as traffic comes inbound on the inside, ingress interface, and goes out on the internet, egress interface, if traffic is sourced from that IP address, then I'm going to do a source NAT, and I'm going to NAT that IP address statically into this IP address. Verification wise, you say show NAT, or show NAT detail, let's say. So it's the auto NAT policies section 2, which is the object NAT, which says I have only one rule, rule number 1. As traffic goes from the inside to the internet, I'm going to do a source static NAT, and I'm going to NAT this source, which is server A, defining the object, into this IP. So it says source origin is going to be server A's real address, and I'm going to NAT that source into whatever I've configured in there. Because it's a static NAT, show xlate, you're going to see the NAT in the statement in there. This shows the translation table. So this show run shows you what you have configured, show run object inline, and show run NAT. This is what I've configured. Show NAT is a verification to make sure that the ASA has properly pushed down in the ASICs the NAT configuration, and it's in a better format. You see exactly which IPs get NATed into which other IPs, and this is the xlet table which we see the entry in there because that's going to be a static NAT. It says flags S, which comes from static. Okay, so now let's initiate traffic from server A to router 4, and as traffic goes out in there, the ASA is going to see source coming from server A 172.16.10.100. But as it routes the packet out on the internet interface, it's going to translate the source to be 136.1.47.100. Let's go on server A and telnet to router 4. Cisco. And if we say who, you see in there that router 4 sees traffic coming not from the real address of server A, but from the mapped address of server A. So if you look in the ASA's connection table, show connection long, you see in here that this is the destination, which didn't got netted. So this is like the real address of the destination real address, and this is going to be in here the mapped address, and it didn't got netted because I'm not doing destination net. But if you look on the other side, so traffic flows out on the internet. If you look on the other side, as traffic comes from the inside, traffic was sourced from this address, server A. This is the real address, and ASA has netted that address into what I've configured, which is the mapped or translated address in there. Now, because this is a static NAT entry, let's go say exit. Because it's static NAT, it means because the translation is always active, as we saw in here, show xlate, the entry is always available in the NAT table. It means that traffic can be initiated both ways. So technically speaking, also router 4 should be able to initiate traffic destined to server A. Of course, router 4 is going to initiate traffic destined to the mapped address of server A because that's what router 4 sees. That's what ASA publishes, that's how ASA makes server A being visible out on the internet. Router 4 is going to initiate traffic destined to the mapped address of server A 136.1.47.100. Let me use a different color in here. So router 4 is going to initiate traffic destined to 136.1.47.100. And as the ASA routes the traffic, is going to untranslate the destination NAT the traffic to 172.16.10.100. But this is not going to work because for NAT to happen, first the ASA has to allow the traffic to flow. And in my case, traffic flows in this direction from a low security level interface of 0 to a high security level interface of 100, which means for this traffic to be allowed by the ASA, it means we have to allow it in an access list. Let's confirm initially that traffic doesn't work. We say clear logging in here, clear logging buffer. And if we go, for example, on router 4 and try to, let's say, ping server A on the mapped address, repeat 2 is good enough, it doesn't work. And if you go on ASA tree show logging, as you can see, ICMP traffic is being dropped by the ACL. So we have to go and change the access list configuration to allow that traffic to flow from low security level interface to high security level interface in there. Which means the second step we have to do in here for traffic to be able to work both ways, to be initiated both ways, we have to go under our access rules, under our configured ACL edit, and we have to add, we have to allow, let's say we want to allow all IP traffic to flow from router 4 to server A, which means we have to add in our access list one more entry in the source criteria. Actually, that's okay. The source criteria is correct. We have to, because that's the source of the traffic router 4, which is in that subnet. But we have to allow one more entry in the destination criteria. And starting with ASA code A3, what you put in there, you're going to put in there not the mapped address of server A, but the real address of server A, which for a lot of reasons makes much more sense. So because I want the ASA to allow traffic, what the ASA is going to see inbound in here is going to see source router 4, destination the mapped address of server A 136.1.47.100. But actually in this inbound ACL in there, I'm going to configure a new ACL entry to allow traffic source from router 4 or the subnet of router 4 and destined to not the mapped address of server A, but to the real address of server A. This is what you have to allow in the access list. So looking at out of ACL, the source is already allowed in the access list because router 4 resides in the subnet, but I have to add the destination to be the real address of server A into this inside networks destination, which actually looking at our ACL show run show access list, traffic from the subnet of router 4, there we go, this line here, traffic from the subnet of router 4 to the subnet of server A is allowed, but I'm only allowing TCP traffic of type SSH and Telnet and TCP traffic of type web. So if I would want to allow all traffic, I would need to add one more entry. Or if I want to allow also ping to work, I need to create actually one more entry with a new service group in there. So I have to make sure that traffic from subnet of router 4 destined to subnet of server A is allowed for, let's say I want to allow all IP traffic back and forth. So I'm gonna add in there one more line, which I'm gonna click on the ACL and say add access rule. I'm gonna say, let's click on the access rule in here and add which we have to say insert. So we want to insert one more line in the ACL. We can insert after the existing rules or before. In my case, doesn't matter. I'm just going to say insert, which means where is that? Let's say let's go on advanced to standard ACL. Probably this to ACL manager. In here, it should be a bit more obvious. We click on that access list. I think that was the problem in here as well. If you go to access rules, we have to click on the access list and say add access rule, or if you go to ACL manager and we click again on the ACL, we say we have add entry in the ACL. So we want to permit traffic from VLAN 47 destined to server A only. So I'm gonna add a new, I'm gonna match on my object, which the object was this, because in that object which I have defined, I am matching only on server A, is the real address. So what I'm saying here, I'm adding a new entry in my ACL saying I want to permit traffic sourced from that subnet, router 4 subnet, destined to that object, which means only server A, and I want to allow all IP traffic back and forth. I'm going to say OK and apply. If we go into configuration now, and if you say show run access list, we should see one more line in the ACL. So this was the first line which I added in the ACL configuration, and in the same ACL we have one more line in here which states permit traffic from the subnet of router 4 to that object, which is the real address of server A, all IP traffic. So now I should be able to also ping, and there we go, it did work. If we extended ping, let's say repeat high count, and if you look in the ASA connection table, show connection long, we see now the ICMP traffic source from out of 4, and of course it's not NATed because at this point the ASA does destination NAT. So configuration wise we've done source NAT, but based on how traffic is being initiated back and forth, the ASA ends up doing source NAT or destination NAT. But configuration wise with object NAT, you always think you're doing source NAT. And then destination, the real address and the mapped address in there.